So you got Genera installed. Now what? In this episode of Genera Gems, we're going to move through the process of getting further down the road on what Genera needs to become fully operational based on instruments that are installed and the workspace you need. All on this part 2 of Genera, Zero to Hero. Welcome, everyone. Part 2, Genera, Zero to Hero. Today is pretty interesting because we're going to move you down the line of how you can get a workspace put together. Because on the part 1, we did a install of the software, and we also installed some packages for instruments. And Igor has a list of those instruments, and we're going to use those to build out Genera even further. So, Igor, give us a little hint of what we're going to do and then just take it away.
Yep. So as you said, we'll be building out the workspace today. So just to give a little bit of background on what a workspace is, so it's a physical representation of all the instruments in the system. And so it's made up of two parts. It's made up of the layouts and the projects. So layout models the physical instruments of the system, such as the robot arm, the instrument nest, hotels, stackers, incubators, etc. And a project is where labware definitions, labware operations, and zones are defined. So let's get right into it and see how to set those up.
Awesome.
So right now, I'm in our tools menu. So this is where we left off in part 1 of our series. And I just added a few more instruments that you would typically see in a system. So I added a reader, a washer, dispenser, liquid handler, robot arm, incubator, and barcode reader. And so to get to our workspace, we're going to go to our editor tab and then click on our open workspace. And as you can see, it's completely blank. Nothing has been added yet. And the first step is to add a layout. And we do that by clicking this plus button here. And we're going to call this our demo layout. And we could set the width and the height of our layout, but for now, I'm just going to keep it at default and then increase it as we need more space.
Yeah, one thing to keep in mind there, sorry, Igor, to interrupt, but one thing to keep in mind there is that 500 by 500 is just, again, a graphical representation of the square that you see on the screen here. And it's just pixels. It's not dimensions of a table or anything like that.
Yep, that is exactly correct. And so first one we're going to add is our carousel. So we have the LPX 110 part of our system. And so we're just going to drag this in. And so this is all drag and drop. Actually, no, we're going to go with the robot arm because that's kind of the central key part of our system. We're going to add this in. We're going to call this our PF 400-1. Gripper orientation, it doesn't really associate to the actual orientation of the grippers. It's more of a graphical representation as well. So if you want it to look like it's in portrait mode or look like it's in landscape mode, you could change that here, but just keep in mind it doesn't affect the functionality of the arm. We can apply labware rules to our nodes. So we could allow certain labware definitions. We could put them in zones. So I'll show this once we add labware and zones to our system. But the most important thing is the instrument we associate to this node here. And so in this case, we're going to associate this to the PF400-1, and we're going to add this in. So now that this is added, I'm actually going to make this a little bigger. So this is all just scalable here. So now we're going to add in our carousel. So we're going to select our carousel node or our incubator. And so we're going to give this a name. So we're going to call this our STX110-1. And our size is going to be 5 because it's 5 hotels. So it's going to be circular because the STX110 is a circular carousel. We're going to leave the visible count to 5. So we want to show all 5 hotels. And we're just going to keep it as clockwise. We can keep that default. And then we're going to add our stackers. So it's a hotel. The size is 22. And we're just going to leave it at the bottom up. And of course, as mentioned before, the most important part is to add the instrument association. I'm going to add that in. and go to add carousel.
One quick thing to point out when you were doing the definition there of how many to view, if you had some sort of carousel that had maybe 10, you could still say view 5. And then at the bottom of that carousel graphic there, you would see a 1 to 5 and then 6 to 10 with a little arrow that would move across. So allowing you to see multiple, there it is, perfect, 1 to 5 and then 6 to 10 if you had more hotels there.
Yep. So like for like an STX 220 or an LPX 220, then that's what that would come into effect.
Exactly.
So there's the carousel, but we also need to add the nest for the where the plate is going to come out of. And so we're going to add the, I believe it's called the STX 110-1-nest. So this name actually is very important. So I'll show you what to name this. But I'll just name this the STX 110-1-nest and then associate this to our STX 110 instrument. And so if we go back to the scheduler view actually, and we were to open up our instrument control panel and go to our STX, go into settings, we could see that the transfer station name, this is what it needs to be set to. So this could be changed, right? So we could call this our STX-nest if we want to, but I'll just leave it at the default. But this is how Genera knows that this transfer station is associated with this instrument here. Because if you had multiple STXs or multiple incubators, then the transfer station names could be different. So this is how it does the one-to-one matching here. And how you know that this needs a transfer station nest is under the information tab. So let me close out of this. Under the information tab, if we go into instruments, if we go under the Lyconic STX, if there's any special configuration when it comes to the layout, it'll always be mentioned in our documentation. So in this case, it says that the instrument should be modeled in the system layout as a carousel, representing the storage positions, and a nest, which is representing the transfer station. And the transfer station name configuration property should be set to the nest name. So if you have any questions about how a certain instrument should be modeled in our layout, they will all be mentioned up here under the instruments tab in the information location. So let's finish building out our system. So we added our incubator and our arm. So let's add our washer and dispenser. So we could give this a general name actually. We just call it my dispenser -1. And we're going to apply the Certus Flex. I'm going to add that in. And then we're going to add our washers. So these are fairly straightforward because there's only one nest with each of these instruments.
And as I watch this, it's really telling is how quickly you're putting together this workspace, this graphical representation of the cell that you're actually utilizing for your operations, and it's quickly moving along here.
Exactly. It's all drag and drop. So this is going to be my reader -1. So these are the ones that are straightforward. There we go. And then another one that is a little different is our barcode reader. So barcode readers are going to be represented as a point. So this will be my barcode reader. And then this will be associated with our SR700. Oh, I spelled that wrong.
Yeah, one thing to remember here is when you're mentioning a node as a point, the robot can utilize that as a point in space to get in front of that barcode reader, trigger the barcode reader, and then move on to its destination, wherever that may be. So that's why it's represented as a point in space, and that's what that looks like.
Yep, exactly. And the last node we need to add is for our liquid handler. So usually liquid handlers have multiple nests on deck, and you could either put all the nests on your layout here, or you could just put the ones that are going to be accessed by the arm. So in this case, I'm just going to put the ones that are going to be accessed by the arm. So I'm just going to put 3 nests associated with our liquid handler. And to do that, we're going to first add a container. So I'm going to call this my liquid handler -1 and associate this to the opentrons. And if you want to add a picture, we could add it in the middle, and we're going to add that container. So what a container does, or what it is anything in the container that I add to it. So let's say I add a nest to my container. It's already going to be associated with that instrument. So I don't need to put any more instrument association. So I just need to call this nest1. And then what's nice about this is I could just copy my nest1 and then paste it inside. And then you'll see it will automatically rename it to nest2. And so I could just keep pasting nest3. And now I have my 3 nest part of my liquid handler.
Yeah, the inheritance property from the container is awesome because it does, like you said, Igor, it transfers directly into those nests. Unlike you see the ones you're just moving now, you see the instrument association already. But because of the inheritance, it's already there. So you won't see the instrument inside nest 1, 2, or 3 because it's inside that container.
Yeah. And the last item or last node I'm going to put in our layout is our hotels. So hotels do not need an instrument associated, unless there's some sort of instrument that has a stacker on it or a hotel or anything along those lines, then we could associate an instrument to our hotel. But if it's a random access hotel, we just call this hotel -1. We could change the name position. We could change the size. So I'm just gonna this is just going to be a 10 size hotel, and we could change the shelf order as well. So we could either have a bottom up or top down. I'm just going to leave it as bottom up. We're going to add that in, and then I'm going to add a second hotel as well. Hotel -2, size 10. And now we've built out our workspace for our system. And so
Awesome.
what we're going to do is we're going to save it, and we're going to move on to our projects. So projects, how to add one in is very similar to the layout. We just click the plus button, type in our demo. It's going to have the same name. And as you can see, we have 3 like tabs here, right? We have our labware definition, our labware operations, and our zones. So we're going to first go through our labware definitions. So we're going to click on this drop-down menu. So there's multiple different definitions we could add, like microplate, tip boxes, tube racks, tubes, lids, so on and so forth. So in this case, we're just going to add our microplate. And so with our labware definitions, we have a few properties we have to fill out. So first is our name, which I'll just call the microplate -1. Description. So this is where you could put information associated with this microplate. So for example, we could put our catalog number, like 1, 2, 3, 4. We could put in how much comes per case. So case number,
case quantities, yeah,
case quantities, whatever else information you want to add that's part of this microplate. You can put your URL in here to show where to buy this microplate, just
great
for
point.
other users.
Yeah. And doing this, what that does is it doesn't isolate that information off of, maybe if Igor has a spreadsheet on his computer with this information, it doesn't isolate it to his PC. Now it's inside the software and you know exactly where those pieces of labware actually come from.
Yeah, which is a very useful tool to have.
Yes.
So after description, you could change the color. So of course, we're going to go with the red. And our plate type. So we could have multiple different plate types, all the way from a 6 well plate all the way to a 1536. So I'm just going to leave this as my 96. actually rename this to my microplate dash 96 to know that this is our 96 well plate. And then we can go into labware properties. So labware properties allow information to be associated with a certain labware. And this information can be used as an input in a process or retrieved directly inside of a script or a program. So this will make more sense once we get to our process development part of our series. But just to show you a few examples, so this could be a labware property called buffer. And then I'm going to add values to this. And this, we're going to add buffer A or buffer B. And so within our decision node, what we could do is when we add this labware to our layout, we could assign it a value of either buffer A or buffer B, and then we could have a decision node within our process that'll select, if there's certain condition, or if it's selected buffer A, then it's going to dispense to buffer A. If it's buffer B selected for our labware, then it's going to dispense buffer B. And we could also give it a default value. So when we add the labware, it's going to have buffer A. And another example is we could have it, each labware could have a certain protocol associated to it. So I could say that, let's say this is protocol A, protocol B, and protocol C. Then let's say I have a reader and different plates require different protocols to be run or methods. When we add, let's say, protocol C to the labware, it's going to run that protocol on the reader. So it's a very powerful tool to associate labware to as inputs in the process.
Yeah, I really like the protocol one because that allows you to, based on, like you said, the individual pieces of labware to say, hey, these I know are going to be run through protocol A, B, or C. So now you're telling the device, based on that labware property, this is what you're going to run because that's what you're going to see.
Exactly. And then one thing I want to add is just a simple lid. So let's say this is just going to be my lid, -1. We're just going to leave it yellow. We could say whether it's an SBS or a P-tree. We could also put labware properties associated to lid, but I'm just going to leave that just to show you how this works. So when I go, after I add the lid for the acceptable lids now, you'll see that there's a lid -1. So I could associate that this, or I could say that lid -1 is an acceptable lid for microplate 96. So now I can add lid 1 onto my microplate 96. So next, we're going to go through our labware operations. So these are operations that are done on the labware as it's going through the process. So these are user defined. So I could call these whatever I want, and I could add as many as I want. So I could say that I have a read operation, a wash operation, a dispense operation, and let's say a liquid handling operation. So as the plate moves through the process, the operation that's associated with the plate will change depending on which operation I add onto it at the certain point in the process.
So these are sort of associated, if I can clarify a little bit, these are more associated to the instruments that they're actually going to, the labware's going to. So like you have the dispense in that operational step, when it places a plate at the dispenser, you can say, hey, now that you're here, the dispense cycle has started, and that labware operation will be now associated to it, correct?
Yes, that's correct.
Okay.
That's a lot better explanation there.
And this is also good for not necessarily, yes, these are great because they are instrument related, but you can also have things related to a labware state. If within your process, some may have it, some may not, you have an incubate timing somewhere. Well, that is a state of the labware, not necessarily associated to a device. So you can also put that in there as well and say, hey, if I see labware on the deck, once we start developing these processes and you look at the scheduler view and you can see a labware has an incubate state to it, Now you know what's going on. And it also has a state, so that will tell you where it is in the operation.
Yep. Or at the very end of the process, I could add a plate
Exactly.
finished operation, so I know that that plate has finished, doing what it needs to do. And then, yeah, we'll show examples of this once we've done building out our layout and project. And then finally, there's zones. So zones is how you pull either instrument or labware locations together. So I think the best way to explain this is actually show an example. So I'm going to have my hotels zone. I'm going to save this and go to my layout. And as you could see, for each of the nodes in our layout, we have a zones tab. And I could apply my hotel zone to this hotel, to hotel 1, and I could also do it to hotel 2. So now I could, for example, pick from the hotel zone when I want to move a labware. Let's say my source destination is my hotel zone, and it'll pick from either hotel 1 or hotel 2, depending on which one has labware. Or I could do the opposite, where I could put the hotel zone as a destination, and it'll just keep filling up either hotel 1 or hotel 2. And if one is full, then it's going to go on to the next hotel. So that's pulling location and then pulling instrument nest. So let's say I had multiple like washers or multiple dispensers or multiple readers even, and I don't care which one it goes to, as long as it goes to one of them. I could also put a washer zone or dispenser zone or a reader zone and then apply those as whichever nest as part of those zones, and then put the destination as that zone. And so as long as one of those instruments are available, it'll move on to that instrument and run the protocol.
Yeah, and the huge benefit to this in either location, in either instance, especially for devices. So if a device in a pool were to go down for some reason, maybe a colleague decided to use it standalone and now it's not available as part of the overall operation that you're running, well, that's no longer available in the pool, but the pool, the process doesn't stop because there's more in the pool. So if you were to take example, dispenser 1, washer 1, reader 1, if they were all the same, they're all part of the pool, and you don't make an explicit declaration to go to dispenser 1, washer 1, reader 1, you just say find first available. Well, if one of those is out, the other two are still there, and Genera will continue to operate because the pool still has resources available to it.
And that covers all of our workspace. So we went through the layouts and the projects. And so to make sure that we've done everything correctly, we're going to go back to our scheduler view. And under the workspace section here of our scheduler view, if we were to drop down on projects and select our demo project and then select our demo layout, we could see that we have our system set up here.
That's great. You've moved so much further along in a relatively brief period of time to now visually seeing on the scheduler view / dashboard view what your system actually looks like. And it didn't take very long to do that. What we're going to do, though, in part 3, we're going to go through the process of actually teaching this deck, but we wanted to get you to this point where you can actually visually see things starting to come together in the software. So Igor, I appreciate all the effort you put into that and how quickly it came together to do that. So for part 3, we'll do some teaching, but that's all we're going to have for this one, and we'll catch you on the next one.